Okay, we're in our last presentation before we go to the break, and it is our lead sponsor, Nokia. We've got Roman Dodin to speak about Devops approach to network labs. Okay.
Hi, everybody. So yeah, thank you all for coming to this awesome event. My name is Roman. I'm part of the Nokia's product management team. But for the course of this talk, it's more important that I'm an open source maintainer and a member of various network automation communities. So with these hats on, I'd like to talk about Containerlab, an open source project that we've created that can bring this DevOps approach to the way we run and manage network labs. But before we jump to the tool itself, let's kind of reconvene on the point that networking labs are really now a right and not a privilege for every network engineer or anyone who owns and operates a network. And you can come up with many use cases for when networking labs are really important and crucial. But I list a few things here that I think are quite common to everybody here. For example, when you want to push a change to your network and you want to ensure that you will not bring down your production network, it's best if you can test those changes on some sort of a digital twin or digital sandbox. And that is where labs are really important and play a crucial role. Or maybe you want to prototype some solutions or design new things. Let's say you want to switch your peering router from vendor X to vendor Y. And the questions come up to your head like, what are the differences between those two vendors? Like, is configuration different? How can I verify that the control plane operations will work the same? And that is, again, something that network labs can help you with, and you can test those things out even before hardware comes to your lab. And last but not least, I think in this room, we have quite a lot of network engineers or engineers in general, and we all learn new things day to day. So how do we learn things? I think one of the best ways to learn things is by doing something hands-on, right? Like learn by doing. If you will have a lab that you can easily spin up on any compute that you have that will answer all the infrastructure needs, then you will probably take your education level to some new heights. So with these kind of important things about networking labs, we at Nokia took a step back 2 years ago, rewind to 2 years ago. We thought, like, can we create a tool that would bring those DevOps approaches? Because we looked at the application world to our older brothers, and we saw that the tools that they use for infra and service provisioning are kind of converged on the declarative workflows. So we thought, okay, can we create a tool that would work the same way, but kind of applied to the networking domain? And that is exactly what we did with a project that we called Containerlab. It takes the typical infrastructure as a code approach, where you define your intent as a set of files, typically written in YAML or any other configuration language, and you define your topology for your lab as a set of attributes, like a set of nodes and a set of links that wire your nodes in a topology. And then Containerlab takes these files and create the lab for you. So that was our initial design. And now I would like to tell you how it all works. And to make things interesting and kind of related to the audience here, I decided to build a small IXP lab today with you. So our IXP lab will consist of 3 nodes. We will have a route server that is powered by OpenBGPD, and we will have 2 IXP members. One IXP member runs Nokia LINX as a peering router. The other one runs Arista CUS. They peer with a route server, and they announce a single route, a typical /32, just for the sake of the simplicity. And the route server will propagate these routes towards the other IXP members. So by the end of this talk, everybody will have their own IXP, so links be ready. And we will see how we can do that with Containerlab. So first things first, let's talk about installation. Now, with Containerlab, we take simplicity quite seriously. We thought that unless installation is that simple, the tool will not fly. So installation is really one command. You can see it on the second line. You use this automated installer script, and Containerlab will be installed on any Linux compute that you have, granted that you will have Docker installed as well. And this binary embeds all the dependencies that the tool relies on. So you will not end up in a dependency hell like with other programming languages like Python. So that is very easy and so far so good. Now let's see how do we create those infrastructure intents when it comes to the networking? Again, I wanted to reiterate on the point that what you need to do is that you need to define your lab as a set of nodes and a set of links. And you capture these intents in a file that we call Topology File. So then Containerlab takes this file and create the lab for you on your machine. Now, let's start writing this file. So first, we need to define a name of the lab. Now, I call it OBGPD here, which is OpenBGPD, a shortened version of it. And then we define our nodes. So we start with the first peering router. That's going to be Nokia LINX. And you see that to define the node, we need to provide just two mandatory arguments. We need to say which kind this node is. And in this case, the kind is Nokia LINX. With kind, we kind of embed what it takes for Containerlab to spin this particular node. Does it need to provide some runtime parameters that are specific for this Nokia LINX? Or maybe it needs some additional files to be created so that the node can run. This is all embedded or encoded in a kind that is for this particular node called Nokia LINX. And the second mandatory argument is the image. So Containerlab works with container images. It doesn't work with VMs. And the image that you see here is the URI for a container image. You may recognize the GHCR as the GitHub Container Registry, and that is indeed true. At Nokia, we publish our LINX image publicly. You can pull it right now if you want with Docker pull command. You don't need to be registered. You don't need to talk to a sales rep. It's really an open and public container image. So you specify this URI here in the topology file, and that's all it takes to define a node in your lab. Let's switch to the other peering router. That is our Arista CUS router. As you can see, to define this one, it's actually quite the same. You change the kind to Arista CUS so that Containerlab knows how to run this particular network operating system for you. And then you change your image to an image that you have for Arista. Now, this is not a public image. You need to register with Arista download website and download the tar archive and load it with Docker command. So there are some steps that you still need to do with Arista. But again, it's free, so you can download it and deploy this lab afterwards. Moving onwards to the route server, OpenBGPD. The community of OpenBGP maintains a public container image for OpenBGP. Same with bind. You can find a container image with with bird. And to define this one, we need to change a few things. First, we need to say that the kind is now equals to Linux. That means that Containerlab will deploy this container just as a regular Linux container without doing anything extra like we did for peering routers. And we also specify the image, which is a public container image pushed to Quay container registry. But what you can also find here quite interesting is that we use the binds instruction. With binds, we provide a file mounting kind of configuration so that we can have a file on our local file system and mount it to the container namespace. That is quite common, like you would do this with Docker run command, for example, and volume mounts. The reason that we do that is that we want our route server to start up with a configuration that already has some BGP configuration that is ready for our peering routers to peer with. And then with nodes kind of created and out of the picture, we need to create a network, right? That is what will glue our routing nodes together. So we need to create an L2 network. Typically, IXPs use some complicated things like LDP-based BGP VPLS or, for example, EVPN VXLAN networks. We don't do this here. We don't want to get into the nitty-gritty details of the IXP network things. We will just create a bridge. And to do that, we will create we create a node of kind bridge. And that is what makes the very simple layer 2 broadcast network for us to connect our nodes to. Now we're at the very last stage where we need to connect our nodes to this network. Just think of the links as the patch cords that you connect to your router and to your virtual bridge. That is what we do here with the endpoints that you see at the bottom of the left portion of the slide. We say that we want to connect patch cord to LINX interface E11. That's going to be our end of the patch cord. And the other end would be the IXP node that is our virtual bridge, and we connect it to interface SRL1. So in the background, it's going to be just a virtual ETH pair between the two namespaces, but you can think of it just as a patch cord. And that's actually it. So we had, I think, like 20 lines of YAML, and that is really the total amount of lines you need to have to deploy this kind of lab. So now how do you do that? You do say Containerlab deploy, and Containerlab takes the file that it finds in the current working directory, parses it, finds out which nodes it needs to create, how to create them, and then stretches these virtual ports between the nodes. At the end, you will see a table that presents you with a summary, which nodes I created for you, which IP addresses I assigned it for the management interfaces of the nodes, so that you can have everything that you need to start managing those nodes. So how do you connect to the nodes? That's actually quite easy. If your node runs SSH server, which most network operating systems do, you do say SSH username and the container name, so that you can connect to the node just like you would have network access to a real switch. If your node doesn't have an SSH, for example, OpenBGP doesn't, you connect to it with opening up a shell through Docker exec command, like you would do with any container that you might run with Docker run command, for example. So every option is available to you. You have network connectivity, so you can use SSH or network management protocols. You can do some automation with netconf, Ansible, Napalm, whatever. You have access to the networking ports. And then again, the lab is deployed. What do you do? You can configure the interfaces. You can start bringing up your BGP peerings. You can play with OpenBGPD and tune it, do some security hardening, ACL filtering, MAC filtering, and so on. And then you can do some nice stuff with RPKA validation and all the things that you want to do within the IXP domain. So I created this lab for this talk, and I published it to my GitHub account. So if you go to the github.com/health/openbgpd-lab, you will find this lab with all the configuration pieces, with the YAML that we just described, and a very detailed documentation on how to run this lab on your own machine. So now a little bit of housekeeping items. It is really easy to get carried away when you configure this stuff with this fancy shiny toy. And you might forget, like, what nodes do I really run? Which names do I need to use to connect to the nodes again? Containerlab Inspect kind of refreshes you on what you have running in on your machine, which nodes you have deployed, what are the statuses of these nodes, so you can connect back to them and see, for example, which IP addresses they've been configured with. And then you want to probably clean this all up once you've finished your testing, you designed something new, you learned something new, you want to get rid of the lab. Containerlab Destroy will get rid of everything that we've just deployed, so you can make your server happy without running those hefty images. And you can use that, you can treat your labs like cattle and not pets. So you deploy it whenever you need, you destroy it when you don't need it, you can recreate the same steps once again when you need it. So no need to have long-running labs unless you want to. So a quick word on the multi-vendorness of the tool. So as I said, although we created this tool kind of in Nokia, we are not a proprietary solution. It's an open source community project. That is why we embedded a lot of different vendors to be supported by the tool. So you can create a lab with that has Arista only, for example, or Cisco or Juniper, or some firewall vendors. So it's all up to you, like what tools which vendors you want to use with your lab. We give you the ammo, and you decide what you want to do with that. So kind of wrapping this all up, Containerlab is a tool that enables you to bring DevOps or declarative approaches to the way you run networking labs. It is working with files which you can check into a Git repository and make your lab really a code artifact. So you don't need to do any drag and drop, point and click kind of things in UI. Your lab is really a piece of code that can be shared through the GitHub or any other VCS system. It is also container-based, so you can build images for different network operating systems and push them to container registries so that your team or any other who has access to this container registry can pull those images and work with the same environment as you designed it to work. It is light and fast. It's just a single binary with all the depths included, and it works really fast because it's just a CLI, so you are as quick as you can type. And last but not least, it's open source. You can check out the code, you can fix things, you can propose some new features or come up with PRs. That's always great to hear. Also, we've built quite a lot of labs with Containerlab, and we showed them on different events. And the catalog is growing, and we try to publish every lab that we've created. So a few labs I showcase here, but we have way more than that. We have a SRL Labs GitHub organization where we push those labs, and everything that you can find about those labs are checked into the GitHub repository. So feel free to check this out, and yeah, and maybe you will learn something new out of those. And last, like, key takeaways from this talk. So Containerlab is a tool that enables declarative or DevOps approaches to the way we run labs. The first kind of stop point that you need to make is containerlab.dev. That is the documentation side of the tool where you will find everything you want to know about this piece of software. It has a lot of documentation around how it works. It has some lab examples with different vendors to keep you to give you a head start with a vendor of your choice. And yeah, I think that one answers a lot of questions about the tool. Also, if you want to chat with us in a kind of instant messaging way, there is a Discord server created for Containerlab specifically. Feel free to join, it's free. Every dev is kind of there, so we can talk to you in a friendly manner. Of course, SRL Labs/Containerlab is the home of our code base, so you can go there, check out the code base, contribute things, raise issues, everything's great. And again, I'm here today, and I joined the social, so if you have some conversations, if you have some ideas, I'm happy to chat with you. So yeah, with that, I thank you for your for listening to this talk, and happy to chat and answer any questions that you might have.
Thank you, Roman. Any questions? Yes, Neil. Yeah.
Hey, great presentation. One thing I'd ask, so imagine there's some network engineers in this room that are thinking, you know, my idea of logging into a network is conft and router BGP 8220 on Cisco. Where would you advise them to start to learn about how to get into this space? Because I feel that we've still got kind of a drag on moving from the past into the future automated platforms that the network really needs to move towards. Have you got a starting point, or is there somewhere that you would point them at?
Yeah, that's a great question. And actually, I've been to many events when I realized that not everyone actually have any experience with virtualized network labs. And I think the way to get into those areas is when you get kind of fed up with the old ways of running labs, when you feel like there is a lot of friction to maintain a hardware lab, to do repatching of your network. That's when people start to think out of a way out. Sometimes it's easier to piggyback on the network automation hype. Like, people want to know, how do I automate my network? And Containerlab is a very nice and easy tool to create this underlay of network so that network automators can start playing with it. But if it's just a network engineer who's happy to configure his spanning tree protocols, there's also kind of a cell in Containerlab that can help them to create those networks at a snap of a finger, really fast and easy. So maybe give them this ability is also a head start.
Thank you, Neil. Any last questions?
Yeah, apologies, because this is, I'm a little bit out of date for the kind of network lab stuff, but well, why would, and what are the advantages, I guess, over your approach over like scripting GNS3? If you, because previously kind of GNS3 kind of servers with kind of a nice web GUI kind of seem to hit majority of it. Is there a reason? Is it that it's YAML is nicer to check into GitHub and create your labs, and it's easier to do it like that versus, yeah, I guess what's the difference of approach? Why would you pick one over the other?
Yeah, that's a great question. I do get this a lot of times. So the thing is that GNS3, you need to install it, right? It needs to run in a network somewhere. So everybody needs to have an instance of GNS3. And it's not a single binary. That's a software that you need to install and probably allocate a VM to that. And imagine if I want to share this lab with a random person here. Will he has or she have a GNS3 running? What if not? Like, with this tool, all you need to have is just a raw compute with nothing but Docker and Linux operating system. And finding this compute is way easier, especially across developers. And when you share this tool with them, they really love it because they don't want to maintain GNS3 or even G instance. Also, you can think of the CI/CD pipelines. What if you want to run a CI/CD where you don't have access to GNS3? So this stuff runs on any compute that you can allocate, and CI/CD can be done there way more easily. And probably the last thing I would like to mention here is that GNS3 offers you a scripting capability, that's true. So you can use the API of that, and even G as well. But it requires you to know how to write these API abstractions. You need to have something that kind of, you need to write some code to call the APIs and deploy the labs. And it's a bit more involved than I would like to, if you compare this to a simple YAML file.
Okay, thank you very much.
Thank you.